Okay, so today we're going to look at two of the homework problems that are a little trickier that you need to draw a tape diagram for. So the first thing we talked about was reading the problem multiple times. You never read a word problem one time and get right down to it. We usually talk about reading it, making some notes, reading it again, circling keywords, reading it again, making a plan, reading it again to see if your plan will work. So you should have about 5 readings of the question. So the first read through, you can kind of think about, is anything coming to mind that you think you should do? So I have a table and 8 chairs weigh 235.68 pounds together. If the table weighs 157 and 84 hundredths of a pound, what is the weight of one chair in pounds? Okay, so the first thing that popped into my mind was that there was some measurement in there. So I'm just going to write that down because I want to be mindful of looking to see if there's a conversion. So I'm going to read it again, and I'm going to circle all my units of measurement. I'm also going to look for keywords. A table and 8 chairs weigh 235 and 68 hundredths of pounds together. So I'm looking at this word together, and I'm thinking maybe adding. If the table weighs 157 and 84 pounds, 84 hundredths of a pound, what is the weight of one chair in pounds? So if I go through here, I see pounds, pounds, pounds. So I'm going to go back to this, what I was thinking, and I'm going to write down that there's no conversion. It looks like I carry pounds throughout the whole thing. Other than this addition, right here, when I saw the word together, I was thinking maybe there might be some adding going on. Nothing really came to mind, so I'm going to write down either picture or a tape diagram. If you get through a couple readings and you're still kind of stuck, start to draw it out. Okay? So I have my table. I'm going to label it table. And I have my 8 chairs. So I'm going to split this part into 8. 1, 2, 3, 4, 5, 6, 7, 8. You always want to count to make sure, because sometimes your drawing can be off a little bit and then it changes your math. So I know these are chairs. So there's my table, my 8 chairs. And I know that together these weigh 235 pounds and 68 hundredths of a pound. Okay. Now they told me the table. So I've got that part. I'm going to plop that in. You know, the table is 157.8 or 0.84. So now they want to know one chair. Well, now that I have the picture, I'm realizing I can get this table part out of it and just isolate the chairs. And I'm going to do that by subtracting. So my original thought of adding, my thought when I saw it together, it shows it in the tape diagram, but I don't actually have to add. And that's why we want to keep reading the problem to make sure that our original instinct is right. So I have this, and I know this part of it is the table. So I'm going to take the table portion out of my original number. So I'm going to take the table right out of it. So I got to go over here, and I got to borrow one. I'm going to borrow one again, borrow one again. Okay, so 77.84. So I'm going to put that on my diagram. So I know those chairs are 77.84. Well, they're all going to weigh the same thing, and I know there's 8 of them. So now I can take this 77.84 and I can divide it by 8 ways because I want to know one chair. So 8 doesn't go into the 7 at all, okay, but it will go in to 77. And it'll go into 77 9 times. So 8 times 9 is 72. I have 5 left over. Bring the 8 down, okay. Decimal always gets carried up, never down. So I know 7 times 8 is 56. 2, bring the 4 down. 8 will go into 24 3 times. So I know each chair is 9.73 pounds. And the picture really helped me with that one. So that's something we want to be thinking about when we get stuck. Start drawing it out. Even if it didn't look like a tape diagram and I had the picture of the table with the chairs around the outside, you know, 1, 2, 3, 4, 5, 6, 7, 8, and I bracketed out and said, okay, I know that's going to be 235, 68. I have something to go from. The tape diagram is a little bit better because it looks more mathematical, but any picture you can draw is better than just sitting there stuck. Okay, this next one. Mrs. Cleaver mixes 1.24 liters of red paint with 3 times as much blue paint to make purple paint. She pours the paint equally into 5 containers. How much blue paint is in each cup? Give your answer in liters. So one of the things I noticed the first read through is measurement. And I also noticed there's 2 paint colors, so I got to pay attention to that. Okay, I'm going to read it again. I'm going to circle measurement and keywords. So liters, okay, times, I'm liking that because 3 times looks like that mathematically. Okay, blue paint to make purple paint. She pours the paint equally. When I see the word equally, a lot of times I know that has to do with division, so I'm just going to notice that. Into 5 containers. How much blue paint is in each? Each, sometimes that can be multiply, sometimes that can be divide. Give your answer in liters. So if I look, I have liters to liters. So I can see there doesn't seem to be a conversion. So no conversion. Okay, and I'm thinking, I'm seeing a lot of like division or multiplication stuff. So it seems to be one of those things. I'm not really sure which one yet, so I'm going to think maybe I need to draw a tape diagram or picture to try to understand more what's happening. So I'm going to draw a picture of what she's doing. She's got red paint, and it tells me exactly how much red. So I'm going to draw this red first. And I know that's 1.24 liters. Okay, so 3 times as much blue paint. Well, here's blue, and I know it's got to be 3 times the red. So I need 1, 2, 3 of those. And I know each of them are 1.24. Okay. So she's doing that to make purple. So she mixed them together to make purple. Now, she's splitting them into 5 containers. Let's figure out how much blue paint she used total, because they're not asking me about the red in the answer, they're asking me about the blue. So I want to know how much blue paint she used total. So I'm going to go through and I'm going to multiply that by 3 because I know it was 3 times. So my answer is, for how much blue paint, there's a total of 3.72 liters. Equally. So I know she split them. She took this and she split it into 1, 2, 3, 4, 5 containers. So here's her 1, 2, 3, 4, 5 containers, and that's a total of 3.72 blue. So if I want to know how much is in each, I can just divide. 3.72 divided by those 5 containers. 5 doesn't go into 3, but it does go into 37 7 times. 5 will go into 22 4 times. Okay, and I'm not going to use the remainder because I know there's a 0 there. So there, my answer is 0.744. So each cup contains 0.744 liters blue paint. And because it's getting kind of noisy here on my paper, I'm just going to bracket that out, draw a box around it so you can see it. And hopefully that helped you with the last 2.